Hi everyone, welcome back. We have already studied about the equations and linear equations. In today's class, let's discuss about linear inequations in one variable. If x and y are any two quantities and we can have four different relations with these two quantities. One is x greater than y, the next one x less than y, then x can be less than or equal to y, x can be greater than or equal to y. These are the four relations we can write when x and y are two different quantities. Here the signs greater than, less than, greater than or equal to, less than or equal to. These signs are called signs of inequality. Signs of inequality. Now let's consider few examples of linear inequations in one variable. 2x plus 5 less than 8, 3x minus 7 greater than 4, etc. are the examples of linear inequations. Now we can see how to solve linear inequations algebraically. Consider the first question itself. 2x plus 5 less than 8. 2x plus 5 less than 8. So whenever we solve any linear inequation algebraically, we need to follow some of the rules. There are 6 rules you need to remember when you are solving any linear inequation. The first rule says that on transferring a positive term from one side of a linear inequation to the other side, the sign of the term changes. That means it becomes negative. Consider this example itself. This 5 is a positive number and we have to transfer 5 to the other side of the inequations. Even every inequation has two sides, that is the LHS as well as the RHS. The terms which are on the right side of the inequality symbol is the RHS and the terms which are on the left side of the inequality sign is the LHS. Now here the first rule says that when you are transferring a positive term to the other side of the inequation, the sign of the term changes. That means it becomes negative. So we can write this as 2x is less than 8 minus 5. This is the first rule. When you are transferring a positive term from one side of an inequation to the other side, the sign of the term changes. That means it becomes negative. In the same way, if you are bringing 8 to the other side, even plus 8 becomes minus 8. The second rule says that on transferring a negative term from one side of an inequation to the other side, the term becomes positive. Let's consider the second example. 3x minus 7 is greater than 4. So we are transferring the negative term minus 7 to the other side. So when you are transferring a negative term from one side of the inequation to the other side, this becomes 3x greater than 4 plus 7. The sign of the term changes. That means it becomes positive. When you are transferring a negative term from one side to the other side, the term becomes positive. When you are transferring a positive number from one side of an equation to the other side, the term becomes negative. These are the first two rules. The rule 3 says that whenever we are multiplying or dividing each term of the inequation by a positive number, the sign of the inequality remains same. So here the sign of the inequality is less than. So here if you are multiplying the entire inequation by any number or dividing this by any number, then the sign of the inequality remains same. So here the first, when you are multiplying with 2, this you get this as 5x into 2 is less than 4 into 2. So you can write this as 10x less than 8. So the sign of inequality remains the same. This will not change. In the same way, when you are dividing both the sides of the inequation with the same positive number, here the number what we are considering is 4. So when you are dividing it by 4, the sign of the inequality remains same. This will be 5x by 4 and we can write this as 5x by 4 is less than 1. This is how the inequation becomes, and the sign of the inequation doesn't change, and in this case also the sign of the inequation remains same. That means whenever you are multiplying or dividing both the sides of the inequation by a positive number, then the sign of the inequality remains same. So the condition is that it should be a positive number. The rule 4 says that whenever we are multiplying or dividing both the sides of the inequation by a negative number, the sign of the inequality reverses. The sign of the inequality reverses. Let's multiply this by minus 2. So when you are multiplying this inequation by minus 2, this becomes 3x into minus 2, 5 into minus 2. So as per the rule, it says that when you are multiplying or dividing by a negative number, inequality reverses. That means the greater than symbol changes to less than symbol. So we will get this as minus 6x less than minus 10. This is how your inequation changes. So the rule 4 says that whenever you are multiplying or dividing any inequation, both the sides of the inequation by a negative number, the sign of the inequality reverses. The sign of the inequality reverses. In the same way, if you are dividing it by 2, by minus 2, you get this as 3x by minus 2 is less than 5 by minus 2. Next is the rule 5. The rule 5 says that when the sign of each term of the inequation changes, then the sign of inequality gets reverses. So consider this linear inequation. Here minus x is greater than 3. So here when you are changing the sign of both the terms of this inequation, this changes to x and minus 3. So as per this rule, whenever the sign on both the side changes, the sign of the inequality gets reverses. So this becomes x less than minus 3. In the same way, if you consider the other inequation, when you are changing the sign of both the terms of this inequation, 3y less than or equal to 18, the sign of inequality reverses. That means it becomes minus 3y greater than or equal to minus 18. This is how the linear inequation changes. So remember that whenever you are changing the sign of both the sides of the inequation, the sign of inequality get reverses. The sixth rule says that if both the sides of an inequation are positive or both are negative, then by taking their reciprocal, the sign of inequality reverses. That means when you take the reciprocal, this becomes 1 by x and 1 by 5. The sign of inequality reverses. That means it becomes less than or equal to. So if x is greater than or equal to 5, when you are taking the reciprocal of this expression, you get this as 1 by x is less than or equal to 1 by 5. That is the sixth rule. So whenever both the sides of an inequations are positive or both are negative, then on taking their reciprocals, the sign of inequality reverses. This is the sixth rule. So all these 6 rules you have to remember whenever you are solving any linear inequation algebraically. Next is the replacement set and the solution set. The set from which the value of the variable x is chosen, and that is called the replacement set. So from which set we are selecting the values of the x, that is the replacement set. And here it is given that x belongs to n. So we can say that the replacement set is set of natural numbers. And the subset whose element satisfies the given equation is called the solution set. And the solution set is the subset of the set of natural numbers, and for what values of x this particular expression or the inequation satisfies, that is called as a solution set. So if you consider the set of natural numbers, we know that it is set 1, 2, 3, 4, etc. It goes up to infinity, and this is the replacement set. Now, when you are considering this inequation, the condition is given that x is less than or equal to 2. So, from this particular set, we need to select those values which satisfies this condition. And here, if you see this condition, we can consider 1 as well as 2 as the answers. Since 1 is less than 2 as well as 2 is less than or equal to 2. So, therefore, our solution set will be set 1, 2. Since this values of x satisfies this condition. Therefore, we can say that the set from which the values of x are chosen, that is the replacement set, and the answers for that particular expression what we get, and that should be a subset of the replacement set, and this is the solution set. Now let's solve few of the sums on this linear inequations. Consider the first question. 8 minus x is greater than 5, and given that the replacement set is set of whole numbers. So when you are considering this question, 8 minus x is greater than 5, we have to bring all the numbers to one side as well as all the variables to one side. I am bringing this minus x to the other side. So as per the second rule, we have seen that when you are transferring any negative number to the other side of the equation, this term becomes positive. So my expression changes as 8 greater than 5 plus x. And now we need to transfer 5 to the other side. This becomes 8 minus 5 is greater than x. This is by the rule 1. Here we are transferring the positive term to the other side. Now 8 minus 5 is 3. 3 is greater than x. Or we can write the same thing as x is less than 3. So the solution for this particular expression is we have to consider all the values of x which are less than 3, and our replacement set is set of whole numbers. So let's write the replacement set. Replacement set is set of whole numbers, and the set of whole numbers are, you know, it is from 0, 1, 2, 3, etc. up to infinity. Now as per the condition, when we have simplified this linear inequation, we got the condition as x is less than 3. So we need to consider all the values from this replacement set which are less than 3. So we can consider the values as the solution set, that is equal to 0, 1 and 2. These three numbers are less than 3, and therefore this is the solution set. Consider the next question. 5x plus 3 less than or equal to 2x plus 18, and the replacement set is set of natural numbers. First let's simplify this. 5x plus 3 is less than or equal to 2x plus 18. We need to bring all the variables to one side and all the numbers to the other side. So this becomes 5x minus 2x is less than or equal to 18 minus 3. I am bringing this plus 2x to the other side. So this becomes minus 2x by the rule 1. In the same way, plus 3 to the other side, this becomes minus 3. That is also by rule 1. Now 5x minus 2x is 3x is less than or equal to 18 minus 3 is 15. Now again we need to simplify. So we can divide it by 3, dividing both the sides of this expression by 3. So we can write this as 3x by 3 is less than or equal to 15 by 3. Here the sign of inequality remains the same since we are dividing it by a positive number. So this becomes x is less than or equal to 5, and this is the final condition we are getting. Now we need to find the solution set. Before that, we need to write what is a replacement set. Replacement set is equal to set of natural numbers, and we know that it is 1, 2, 3, 4, 5, 6, etc. up to infinity. Now we have to see the condition. The condition says that you need to consider all the numbers from the replacement set that satisfies the condition x less than or equal to 5. The number should be less than or equal to 5. So our solution set will be set of all. We can write 1, 2, 3, 4. All these numbers are less than 5, and we can even consider 5 also because that is equal to 5. So the condition says that x is less than or equal to 5. So the solution set what we are getting is 1, 2, 3, 4, 5. Now these questions are for you. You can solve it and let me know the answer. That's all for today. We'll meet in the next class and study about the representation of solution on the number line. Thank you.